Let's consider forces. Our first unit is talking about intermolecular forces, but first let's talk on a large scale. Forces that control us as people and objects that we can hold and handle and see. So on a life-size scale, what are the forces that mostly dictate our physical behavior? Not our mental behavior, but how those forces affect us physically. So there are two basic forces that affect us. The first is gravity. We are greatly affected by gravity. The Earth is very large, has a great gravitational field, and it exerts a force on us, pulling us to the surface of the Earth, keeping us grounded. So it's the reason rivers flow downhill. It's the reason it takes work to pick something up. The other force that greatly affects our lives is that due to friction. So friction, if we're walking down the sidewalk, there's friction between our feet and the ground. If we're driving in our car, there's friction between the tires and the road. And that's actually a good thing, because if we are driving down the road and the road turns and we are in our car and we try to turn our steering wheel, and it's because of friction between the tires and the road that allow us to accelerate, change directions. And if there was no friction, we would just keep going straight, and driving would be very problematic. So now let's consider on a small scale, say like the atomic and molecular scale. What forces are acting and dictate the behavior of particles on that type of scale? Basically, there are three other forces in nature besides gravity: the electromagnetic, the strong nuclear force, and the weak nuclear force. These two are very short-range forces and act in the nucleus of atoms, and so they really don't affect us chemically. Chemistry is concerned with the rearrangement of electrons and bonds. So basically, what controls chemistry is electromagnetic force, and the magnetic force is much weaker than the electric force. And so basically, what controls chemistry is the electric force. So we have a nucleus, and we have protons, which are positively charged. We have electrons, which are negatively charged. And there is an attraction between the nucleus, the proton, and the electron, which are oppositely charged. And there is a repulsion between two like-charged electrons. So when we form a chemical bond, say the hydrogen atom, we have, I'll draw this a little differently. You have a nucleus with a plus, a nucleus with a plus, single protons. We have two electrons, and the forces balance in such a way that there is a net attraction between these two atoms. And so they are held together to form a chemical bond. So in this chapter, we're not as concerned about bonding between atoms, but we're concerned about forces between molecules themselves. So we're going to talk about these forces, and I'll list them here. There's ion forces. There are ion dipole forces. There are dipole forces. And finally, there are what are called dispersion forces.